everyone. Welcome to Manufacturing Hub. This is episode 222. That's got to be a lucky show, Vlad. My name is Dave Griffith. This guy over here is Vlad Romanov. We're super excited to have you guys here on the show. Every once in a while, Vlad and I do a show together where we share some of our experiences. We also do a show where I announce our last names. So episode 222 is one of each of those. If you guys have been here before, welcome. Welcome back. If you guys have not been here before, welcome for the first time. If you guys have not been here before, you're not familiar with the show, you've recently connected or found, every month to pick a different theme. This month we're talking all about data manufacturing intelligence. And today Vlad and I are going to go take those building blocks and put it back together and share some of our experiences. I'm excited to see what you've come up with, Vlad. I'm excited to see what you've come up with. If you guys have questions or comments as we're going through this, questions for Vlad or myself, or tell us we've done everything wrong, love to hear them. Please go ahead and drop them in the chat. We will do our very best to go and bring those questions and conversations in during the show, which is one of our most fun things to do. So without further ado, everyone, officially welcome to Manufacturing Hub. This is episode 222. I have one fun initial note, or maybe two fun initial notes, before we jump in and I ask Vlad to explain who the heck he is and why he's here sitting next to me on the show. One, if you guys have been following us for, oh goodness, me personally, for nearly the entirety of the time I've been on LinkedIn or the show, you know that we've done and talked a lot about Ignition. Ignition 8.3 beta has officially launched. Luckily we're not holding our breaths for the launch, since we first started talking about it in very excitedness back in September at the ICC. So Ignition 8.3 beta has launched. We're super excited to go have it out in beta and go talk about maybe some of our experiences and certainly some of the experiences of the other users. Now, over the next probably 6 or 7 weeks before the Ignition Community Conference, Manufacturing Hub is planning to be at the Ignition Community Conference. We're in Sacramento this year, the week of September 14th. The Tuesday, Wednesday, Thursday. So we'll have a bunch of fun content and other things coming out through there. One other inductive automation Ignition ICC note. Next week, we'll have Kevin McCluskey join. He will join us to go talk about a little bit about ICC, a little bit about Ignition 8.3 beta. And so that is definitely something that you guys don't want to miss. We'll have the event up in the next couple of days. It will be about 75 minutes earlier than our normal scheduled show, but still Wednesday afternoon. Having said that, Vlad, welcome to the show.
Thanks for having me, Dave.
Absolutely. Vlad, I feel like we've had a lot of guests on recently, or a lot of people following our guests, a lot of commenters and other things who maybe don't know us. So I know brevity is not our strong suit, but do you think we can do relatively short introductions?
We'll do our best.
Okay.
Yeah, so I guess I'll start with that. If you want to see the full profile, you can definitely go on my LinkedIn. But in brief, I work with manufacturers of different sizes to help them modernize their operations, usually bridging the gaps between legacy systems and today's technology. So I work directly with engineering and operations team to assess their current state, design scalable architectures, and implement solutions across control systems, SCADA, and primarily MES, I would say, infrastructures. So if it's unlocking critical data from PLCs or leading full digital transformation initiatives, my goal is usually to help plants run better from a technical standpoint.
Very impressive, Vlad. I like that. We should ask you to go do things nearly off the cuff more often. Everyone, how's it going? My name is Dave Griffith. I've spent the last 16 years in automation and manufacturing. I have I guess my technical background is in aviation and aerospace. My my other background very much spans the distance from medium to large sized OEMs, everything from that aviation and aerospace to OEM manufacturing. I do a lot of food and beverage. I'll do a little bit of a whole bunch of things in between. The last 7 or 8 years of my career have very much been data focused. 8 or 9 years ago, I found inductive automation and ignition. I've done a lot of work and have built a niche group up who does a lot of work on the ignition side, on the ignition team within Kaplan, my company. And then from that, our goal is very much data focused of how we can go collect, unlock that data for organizations and how we can go turn that into projects that have return on investment, which for me are the most interesting parts. What we'll do, as we maybe will talk a little bit about here, some much larger systems, some much larger complete retrofits. But our
Mhm.
focus is very much how can we go unlock the data that either does or doesn't exist so that we can go create better operational efficiencies.
Good. I like that.
Absolutely. I do want to give everyone a brief theme recap. So, if you
Mhm.
guys are catching the manufacturing intelligence section of this for the first time, this is our fourth episode. I feel like we've got all of the building blocks and we just do want to go call those out. So, we had Brian on episode 217. We were talking about very much kind of collecting data from the plant floor. What are those very early steps? What sort of
Mhm.
issues may you run into? What sort of unified namespace or other frameworks might you go through the process of using? On episode 219, we had Jaron come on and we talked about historians. We talked a little bit about legacy historians, but then we also got into what does a new modern historian look like? We talked about historians versus time series databases, a little bit versus SQL databases, and very much when does a historian kind of fit into the path of a end user of going and collecting this data. And then last week we had Caleb on episode 221, where we talked about MTP, MCP, and very much safe AI. At least that was the concept. I'm not sure we got much past MTP. We basically talked for 75 minutes about MTP, and then how and why we see that as a potential foundation for AI, and some of the really cool tools that Caleb is using on the Siemens side and on the Siemens Tiger team side. I think this is the fourth time Caleb has joined us. Over the course of Manufacturing Hub, dating all the way back to episode 66, and then earlier this year, we were talking to him at the Prove It conference as well. So Caleb is always fun. I'm not sure we've ever overlapped any conversation whatsoever with Caleb. I feel like they've all been very distinct and different topics, and I always 100% appreciate that. Having
Mhm.
said that, our goal of this conversation is what we've kind of internally titled implementation, or putting all of the things that we've learned together. And so Vlad and I have a couple of stories that we want to go tell and share about our experiences going down this path. And if
Yeah.
for our longtime listeners, Vlad has promised he has a short story that he wants to go kick us off with. So we are very excited to hear what you've got today, Vlad.
Yeah, absolutely. So again, maybe to take a step back, right? I've worked on very different, I want to say, data initiatives. I think it was interesting to have very specific business cases for some of these stories, but more importantly, again, maybe easy to recognize or relate to for some of them, right? So early in my career, this is year 2015, maybe early 2016. One of the tasks or projects that I had to basically lead was an energy monitoring project. And so, again, to be completely clear, and I don't know, Dave, if you've had this experience, but it's very rare for a data collection project to be a standalone initiative. You always want to tie this back to some kind of a business use case. And so basically the company I was working for at the time, which was Procter and Gamble, you can find this on my profile, was looking to reduce the energy usage of that specific plant by 20%. And so initially, as the project kicks off, you have a very vague business statement, right? We want to reduce by 20%. We don't know what data we currently have. We might be able to collect some information. Of course, the first source of energy consumption is going to be your utility provider, right? So if
Mhm.
you look at the bill, generally speaking, you can understand how much power you're using, your power factor, and basically how much you're being billed on a specific period of time. The next question becomes, well, can we separate the areas? Because if you're just looking to decrease the power usage of an entire facility, it's very hard to do by not necessarily knowing which line consumes more, which area
Mhm.
consumes more. So at the time, we had three major areas, and that was, production, that was basically your warehousing, and there was some utilities, and this was just based on MCC buckets. And if you're not
Mhm.
familiar with MCC buckets, it's just a very large cabinet where you have multiple drives. And so, usually on the front panel, depending where it's located, you're going to have some kind of a monitor that has basically clamps on the three phases that are coming in,
Mhm.
from the main utilities transformer that's going to step down. I think it's 16,000 volts down to, like your 480 or 600 if you're Canada versus the US. So, anyways, at every MCC, you have some data that you're able to look at. Again, it wasn't clear enough what each line was consuming, but it was clear that the production area was the bulk of the energy consumption, as you would expect, right? Again, depending on your business, it's probably going to be different. But long story short, the decision needed to be made. How do we actually collect that data, right? There was insufficient data to proceed with the solution for that specific business case. So there were three things that were discussed. So number one, you can put a energy monitoring that is basically standalone, right? So you can carry a physical meter, you can put it on the line with clamp meters, and it has
Mhm.
an SD card or USB stick, whatever you
Mhm.
need, to store that data within the panel, right? So and I had done that exercise, right? So I asked the electricians, like, hey guys, like let's put this meter on this line, let's move it to another line. So basically, you need enough data to collect the energy usage between the lines. The other option was, of course, to use a way to collect that data through the existing infrastructure, right? So through the control system. And by the way, the reason why, I guess, like taking another step back, the reason why I'm explaining this is because these are real conversations when it comes to data collection. There's never I want to say, solution A or solution B. There's always a discussion to be had. What are the pros and cons? What are the maybe long-term advantages? What are the drawbacks? How much it's going to cost, right? It's not, obviously, the financial side is very important, but there's other components to this. And so the solution that we settled on, I probably would have done it differently looking back at this project, but basically we implemented the Rockwell power monitoring solution, and they provide these, again, like meters that can be this basically mounted on every single panel. You can put them on every machine, you can put them on the entire line. They clamp on the back, they have an Ethernet port, and they basically report to a central system that gives you kind of like this dashboard that allows you to drill down. Hey, this is the line, this is the asset, and it gives you some general recommendations, right? Of course, if you're going to start with a more proprietary solution, there's going to be some trade-offs, right? So you're going to not necessarily own the data. Of course, you can tie into the meters as well on the side, but basically you're allowing that system to process the information and spit out whatever results it's giving you. And so then you start making certain decisions, right? So for example, if the line is not running, let's shut down these top three like conveying systems instead of leaving them running. And slowly but surely, you're going to get to that 20% benchmark that you set out to be. And of course, the complexity of how you're going to utilize that data to get the business result depends on, your operations, your willingness to change some of those parameters, the accessibility you have to your control system, what kind of maybe other solutions you're looking at. Again, there's going to be always kind of low hanging fruit, like lighting, for example. If you're running still on incandescents and you replace to LEDs, that's kind of like an obvious type of a joke. But ultimately, if you're talking about control systems, maybe it's more efficient drives, maybe it's maintenance or better maintenance of your drivetrain. So there's a lot of things you can get once you have the information or data from your solution to understand the process better. I'm going to pause there. Dave, any questions, thoughts, comments, concerns?
I do, yeah. I've got a couple of questions for you, Vlad.
Yes.
So you said that the business case was we want to reduce the consumption by 20%. Was there reasons behind the we want to reduce consumption by 20%? Is that something that you had visibility in, or did they just kind of come to you as the maintenance manager at that point and say, hey, Vlad, we want to go reduce energy consumption by 20%, make it happen?
At that time, I didn't have a lot of input, right? This was a
Mhm.
global initiative sort of
Okay.
pushed down by corporate teams.
Absolutely. I always find it interesting. Um, where and how and why we come
Hmm.
up with energy reduction, and especially like a number like 20%. I've certainly seen global companies come through the hey, we want to go work on a green or a sustainability, although it was probably more
Yep.
like a green initiative back in 2015-ish. I've also seen like power companies come to some of these major players and have the conversation of you've got too much draw. You have to go through a process to go reduce
Hmm.
that energy. Then I once did a project, and one of the lagging issues with the organization is every so often, like they would just lose power. And like every so
Yep.
often, like by most recent count, it was like 26 times in the last 12 months. And I'm like, that is terrible. You guys have
So,
to have
yep.
better backup generators if you're going to lose power more than basically more every week and a half.
So it's interesting that you say that, right? Like on another
Mhm,
sort of side note, because it was done in parallel with this entire power monitoring initiative,
mhm,
it was also uncovered that basically that specific site would lose and not lose power, but it would be a blimp, right? A
mhm,
very brief duration where power is lost and then restored
mhm.
9 times over a course of a year. Right. And
Okay.
so imagine for like half a second, you lose power 9 times of the year. Well, you think, well, what's the problem with that? Well, the problem is that the lines on the manufacturing side would not come to a controlled stop. They would
Mhm,
basically crash all the servo drives. Everything would go out of alignment. And what does
mhm.
that mean for production? Well, it takes half an hour to an hour to start up. And
Yep.
so obviously I cannot share the explicit costs, but what was agreed upon is that we would put capacitor banks,
Mhm.
and we're talking several millions of dollars worth of capacitor banks to sustain through the majority of those blimps,
Yeah.
right? And that was kind of like the solution on the energy side, but it was also uncovered as a result of this power monitoring initiative that would give us the granularity of that data and actually like understand, is this half a second, is this 2 seconds, because people need to have that information before they make a decision and obviously a purchase of that size.
Agreed. And it's
Yeah.
surprising that it could happen almost a power blip could happen almost once a month and catastrophically take the line down for, I don't know, we'll just call it round numbers 9 hours over the course of a year. Are
Yep.
you losing production? And startup from a stopped, continuously running line is always the worst time. You always go find all of the issues you have as you are starting up, and to go do that an extra once a month would be really difficult. Now, on this project,
Yep.
was that a project that you've talked about power factor correction in the past? Is that
Mhm.
something that you were doing on this project?
So obviously the meters report power factor at
Hmm.
this specific plant. It was really good. My comment and I guess statement around power factor correction was a
Hmm.
different facility. And I guess in
Yeah.
short, they basically had a very large bill. You were mentioning like the utilities are going to
Hmm.
penalize you. I've not been in a situation where they're threatening to, I guess, seize service.
Hmm.
They're going to bill you
Yeah.
excessively until you fix the issue, right? So they had such a bad power factor that they were just getting penalized on a financial side for that, and
Hmm.
they needed to correct it to, I guess, eliminate the problem.
On the one that I had mentioned, it wasn't a job that I did. I just came in on the back end, looking at the data and the information and what we could do with it. I think it was like a specialty chemical company, and
Hmm.
they in fact were using so much energy in a place that apparently didn't have enough energy to spare, that they had huge cogen generators that they were contractually obligated to run some like 8 hours a week,
Oh, it's
24
probably
hours a
during
month.
peak, right?
Yeah,
During like the
you
peaks,
would
I'm
think
assuming.
that, and that was in fact going to be my comment, Vlad.
Mhm.
Having looked at the data and the information, there is no rhyme or reason as to when they were running it. And
Mm.
one of my immediate pieces of feedback is, hey guys, like we can go see how much they're charging us. We can go see when peak is. If we were to go run it during peak, we are going to save 3x the amount of money. In fact,
Yeah.
we can go calculate out how much it costs us to go run the generator, and we may decide to go run the generator, the gen sets longer because it's less expensive during some of those highest peaks than it is otherwise. And so it's always very interesting. I would agree that when you look at energy monitoring, it feels like it should be a good entry point into let's go look at the data, and then what sort of information will that go through the process of providing. As
Yeah.
to if this, for instance, is the entry point for a bunch of other data collection, a bunch of other data visualization, is a completely different story. I guess my only other question for you, Vlad, is you've
Mhm.
talked about the Rockwell the Rockwell energy monitoring solution.
Mhm.
Let's say fast forward to now, 10 years in the future. Is that something that you would suggest or recommend? Would you go down a different path? Would you go build it yourself? If you're an outside source, we've done an energy monitoring build probably 18 months ago, to show how
Yeah.
easy it is to get started. Not completely done, but we've shown how easy it is to go get started. From your experience, do you have any thoughts on the direction that you would go?
I think, look, I mean, obviously depends on the customer,
Hmm.
right? And I say that because I think number one, platforms that you select obviously matter in terms of what's already in place. Because
Hmm.
if you have a majority of your control systems on, let's say, Rockwell in this case, and you're going to put in power monitoring by Rockwell, you can, pass and get some information between the PLCs. Whether you actually do that or not, maybe is a second question.
Hmm.
But I guess there is an easier path to utilizing the same system, right? Your integrators are usually going to be
Hmm.
familiar with, one or two ecosystems. Your
Yeah.
support tickets are going to be easier to handle. If I had absolute, how would I say it, full say, and I had no connection to the control system, I probably would use something that is more open, right? The
Hmm.
reason I say that is because, at least my perspective is that if you're going to go down this path, which is understanding how you use energy, but and hopefully, right, hope, and I say that hopefully because
Hmm.
it doesn't always happen, actually use the data to better the facility. I think you should be responsible for understanding the data. You should be, and again, this obviously is teams, right? This is not, I'm not saying
Hmm.
like you as in like the owner of the facility, but the team should be responsible for getting that data, understanding that data, understanding if they need maybe more of these energy monitors, right? So they should have more control than I would see in some of these more closed off types of systems. And I think you can do a lot more by, again, tying this back into your controls and seeing what impact do those initiatives have. And if you have a team that's actually going through this, I think they will find more
Hmm.
value in a more open solution.
Absolutely. I agree. It if a group is has committed to one
Mhm.
technology platform, I I almost never am going to attempt to convince them to go in another direction unless they've already decided that it's time to go in another direction. And I've certainly worked with groups that have decided that, hey, we're done with this platform, we're ready to go modernize. We don't want the updated version of this platform. We want something different. But specifically on the Rockwell side, if groups have committed the time and money and resources to going and building everything in the Rockwell ecosystem, unless there's a particular reason, it would be really difficult. And I almost never am going to go through the process of convincing them otherwise.
I see. I agree with that argument to some extent. I think there's still some decoupling. So, if you look at the larger, I want to say, vendors of solutions,
Hmm.
some of their platforms play nicer with each other than others, right?
Yes.
So, on the energy monitoring side specifically, and it's not a comment towards Rockwell, but sometimes it
Hmm.
feels it's kind of its own department, right? So
Hmm.
there are some ways, and it feels kind of like the vendor, but it really is a different solution altogether, almost, right? So I
Absolutely.
think that yeah, so I think like your comment makes sense, right? But I would evaluate it a little bit deeper. If it's, PLC and HMI, like absolutely. Usually those come kind of hand in hand, but there's a lot of vendors where they only make PLCs or they only make HMIs. So there's maybe a way to decouple between, let's say you have this platform on the control system side, you pick something completely different for energy monitoring and sort of go from there.
Absolutely. I would agree. And if I may kind of transition
Yeah.
into the next story, before I do that, I will let the folks listening at home know that if you guys have questions or comments on Vlad's energy monitoring story, on the data and manufacturing intelligence theme, or the stories I'm about to go tell, please feel free to go say hi. Let us know where you're listening from, and go ahead and ask those questions. We do enjoy we do enjoy being able to read all of the comments. So I would say almost the opposite of Vlad's story of working for some of the largest Fortune 50 companies in the world. Most of the work that I've done is on the smaller to medium sized groups, and
Mhm.
smaller to medium sized groups is typically upwards of $200 million a year, or less. That is the majority of the groups that I work with over the past decade. Almost, I don't know, probably 80% of them have been what I would consider older facilities with minimal networking. In fact, sometimes calling it networking would be offensive, and low to minimal data collection. And a couple of kind of brief asides. In some of the facilities, they may, in theory, have data collection, but then you go to actually dig in to understand what has happened, and oh, we don't have that information, or oh, all of the tags were for whatever reason set to forcibly change every 24 hours, and we don't know how many months or years that this has been going on. Or in a couple of the groups that I work with who have a bunch of the infrastructure, they find a reason, they find an issue, and it's like, oh no, we found this issue. Now let's go add the tags into our Rockwell historian or into our Pi historian. So the next time we find the issue, we are now tracking that information. So everyone knows that is very typical for me. Um, and then, as at least Vlad has heard, I've been doing some amount of work in pet food recently. I've done 2 or 3 pet food facilities in the past 7 or 8 years. And then on my development side, those guys have done several other significantly large pet food facilities. So this is perhaps a bit of a combination of several sites and kind of reoccurring issues that we see. So specifically, when we go talk about pet food, basically coming in, the problem statement is that the variance of the raw materials is too high, right? And specifically, we're losing some unknown number of millions of dollars a year in raw materials annually, and the issue being, one, we're losing this, and two, we don't know the specifics. And so while systems, at least at older facilities in theory, exist, we may not be monitoring that, or we may not be collecting that data and information in order to successfully say, hey, I needed 1 gram of, call it fish oil, for instance. And instead of 1 gram, I got 12 grams of fish oil over the course of this. And so there are some materials that are more expensive. Fish oil is a good example. Krill is a good example. Things that are more expensive. I was Googling as to what a 55-gallon drum of fish oil costs earlier. Google did not have a good answer for 55 gallons, but if you want to go buy a gallon of it, you're floating somewhere between about 20 and $50 per gallon.
Hmm.
So that gets expensive when you're doing 40, 50, 60 million pounds of dog food over the course of the year. On the inverse of those raw materials, the expensive ones, you'll have inexpensive things. You'll have corn, you'll have barley, you'll have oats, where those are significantly less expensive, right? And so a pound of that doesn't necessarily matter. But if we have variance in our inventory of 10 or 20 or 50,000 pounds, that becomes expensive at volume.
What do you mean
And so
by variance? Sorry to interrupt. When you mean variance, it's the quality of the raw materials?
it's
Let's say.
less the quality of raw materials and more the quantity of raw materials. Uh, so
Hmm.
in many instances, we're going through the process of, let's say we need 10 pounds of corn, right? Let's say we need 10 pounds of corn. And so most of the time for larger things like that, we have basically screws, right? So we've got big
Yeah, yeah.
bins. The
Hmm.
bins have, I mean, I am
Hmm.
describing it as much for the people at home as we are for you, Vlad, but we've
Hmm.
got big screws, and the screws go in. We take our corn and we go through the process of putting it into the mixer. Somewhere in there, maybe multiple somewhere in there, we have weigh scales. Uh, Depending upon the system, I've seen it done a couple of different ways, right? So on the newer systems that I've built, they'll go through the process of basically all of those have VFDs in and of themselves because we're spending tens of millions, maybe 100 millions of dollars on a new facility. So each of those bins will have VFDs. Each of those screws will have specific VFDs attached to them, so that we can have the tightest tolerance of that amount that goes into that weigh scale. That weigh scale area. From that point, those go and get dumped. In some older facilities that I've been to, and I've been to probably two or three that do similar ways and similar things like this, it's we don't have VFDs on all of these because we have, 50 to 100 of these different silos. And an extra 50 to 100 of these silos gets very expensive very quickly when we talk about another 100 VFDs throughout the course of this process, plus the cabinets, plus everything else. So instead of having a VFD on each of the screws, we do some sharing of VFDs and we just kind of bump it, right? And so as we're bumping it, we lose the tolerance of that. And so that in and of itself is an issue or a potential issue, depending upon how tight the tolerances need to be. Beyond that, we run into the issues of, if we are expecting, call it 10 pounds of this particular item, some systems are only set up to say, yes, we've got 10 pounds, go dump, open it up, dump into the mixing vessel, and no longer pay attention if that screw continues to turn and we have an additional pound or 2 pounds or however much of that corn, of that other material, which in and of itself is a problem, right? So sometimes it would be out of spec. Out of spec is a potential problem. Sometimes we may not necessarily read out of spec because we might not check for some of those things. But there are, when it comes to pet food, some things like fish oil that are expensive, some things like krill or other items that above a certain quantity could in fact go kill a pet. No one wants to go do that. So that is kind of I will pause for a moment, but that is generally the problem statement of, hey, we don't know exactly how much raw materials are going into each of these batches so that we can count these raw materials. And I mean, by my rough calculations, some of these facilities are losing 2.5, 5, or more $1 million a year in the raw material loss that they can't account for because they don't know where it goes. And so at some level of frequency, they're just writing off millions of dollars of lost raw material.
Yeah, I think this makes a lot of sense. I guess what you're describing is very similar to what I've experienced at the peanut butter facility, right? It's just
Absolutely.
basically those screws and
Yep.
hoppers that are feeding ingredients in.
Hmm.
I don't know, on that side, I guess it's still very hard to capture data from those, like, those devices are obviously connected to a network, or at least to a computer that
Hmm.
reads out the information. But ultimately, as you said, I think the mistake that a lot of even engineers make in that instance is that usually they're calibrated for something fairly simple, right? So if it's
Hmm.
like water, and I ran into this issue, on the peanut butter side, because you bring in flow meters to understand exactly like how much peanut butter are
Yep.
we making, how much is going through the pipes.
Hmm.
Well, the flow meters give you specs on water, right? And so
Yes.
depending on the state of peanut butter, it can either be a solid or liquid,
Hmm.
depending on the
Hmm.
temperature. And so the
and
same
and
thing
it's
applies
never
in.
and it's never the viscosity of water. I've done
Exactly.
similar things with chocolate before, and so you
Yeah.
have to go through the process of recalibrating those. Now, some good flow meter companies will go calibrate those things for you, if you let them know. As to what the accuracy looks like is a different question. So I would
Right.
say once we have kind of defined that problem statement of, hey, we're losing money because we cannot go through the process of measuring it. The top level issue is data collection, right?
Hmm.
And on many of these older legacy systems, I don't want to go through the process of changing code on PLCs. I don't want to go through the process of wading into databases that we know don't particularly work. So, in a couple of these instances, it was, let's go bring in a solution, let's go connect to the weigh scales, and let's go through the process of measuring each of the ingredients ourselves. It does get a little bit more difficult because there are basically two paths that you can go about doing that. If best case scenario, the peanut butter facility or the pet food facility runs one type of peanut butter or pet food 100% of the time, you know that this is the mixture, this is the recipe. In all of the worlds that I've ever lived in, that is never the case. So we
Mm.
can go through the process of building a batching recipe solution to be able to go understand what the formulations in the batch and the recipe should look like, and to go be able to pull in the schedule so that we can go correlate that. Or you can go through the process of doing that like very painfully and manually. I would say if you need to go prove it out, you can go prove it out manually. I would never want to go commit someone spending, I don't know, 25% of their life going through and matching up each of those batches, as to where they're supposed to fit up. So in almost all of these instances, if we needed to go continue on the prove out, after we went through that process of proving it out, we were going and building that solution because that generally is part of our larger solution of, hey, we need to be able to go automate this so that we can go track the batching and the recipes and the formulations over an extended period of time. And then depending upon the different solution, I mean, best case scenario, you can go connect into those weigh scales. Those weigh scales are just, will go through and weigh everything that falls from the bins, everything that falls through the screws. So if I'm expecting 10 and we really get 12, I can go measure 12. If it doesn't, then it becomes more complicated of, how do I go through the process of weighing that? But we'll say best case scenario, we're able to go in and tie into these. And once we're able to go tie into these, we can go measure, we can go measure that we're actually getting, call it 10 or 20% overage. From that point, then it actually gets interesting, right? Like then the real engineering work can go through the process of starting, right? So best case scenario, it's we're going through and tuning some PNIDs, or we're going through and tuning some PIDs. We are going through and trying to go decrease the variance, and that is a lot of fun, generally for some guys named Vlad. It's typically not a lot of fun for some guys named Dave. But we're going through and we're tuning the PIDs. From that point, we're going back and watching, right? And so at some point, it really depends upon the amount of additional overage. And it's almost never underage. It's always how much of overage are we comfortable putting in, right? So if we're looking for 10 and the closest we can get is like 10.2, is that close enough that it allows us to go continue down this path? Sometimes it's yes, sometimes it's no. If the answer is no, then we look at putting more VFDs on each of those screws so that we can get even tighter accuracies as we go through that. And then depending upon what those other kind of more expensive ingredients are, it may be instead of screws, do we go change to something else? So like, so that we know, this vessel is a cup, right? And like, say we always put a cup of fish oil. We'll continue on the fish oil example. Let's go put a cup of fish oil, and all of it, it's maybe more, but it's never under. Then we'll just go have that vessel that we know is always a cup. We'll go fill the cup. We'll go dump it out. We'll go kind of continue down the next path. Then there are some questions as to, do we make physical changes in the process? And those sometimes make the most sense. And you're like, man, wouldn't it be perfect if we could go measure, the specific information? Like we've got 3 silos, 3 major bins that come into the same place. They all get dumped into the same mixing part. Wouldn't it be great if we could go measure those individually? And the answer is absolutely yes. Now, if we could just shut down the facility for 2 months, cut a bunch of metal, reshape a bunch of metal, and do all of that, it would make our lives much simpler. But that's almost never, in my experience, the real use cases. In the going through the process of building new facilities, it's the let's go think through these problems so we don't go run through these problems a second. So we don't go run into these problems. But in a lot of these older facilities, it's how can we go make this as close to ideal as possible. And then after we've collected that, after we've done that, it's very much, what does the information tell us? Because very similar to your power information, Vlad, where we've learned that we've got 9 blips over the course of the year, and it costs us 9 hours of downtime plus all of those thrown out stuff that's on the line as the line crashes. It's kind of very similar as to, you go through the process of you're collecting some of that data, and once you start collecting that data and you're able to show people that data, then it's like, man, this is really good. Like, I love seeing this. Like, let's go look. And I also want to go see the information on the back of the line where we're bagging or packaging. Like, do I have some of these packaging areas that run better than other packaging areas? And why does that happen? And do I have some palletizers and wrappers that do better than the other palletizers and wrappers? And why does that happen? And can we go through a process of upgrading some of these? And then at some point, it's kind of the middle of the line of, how do I go through the process of speeding up the middle of the line so that I can go ship more than 40 or 50 million pounds of dog food over the course of the year.
Speaking of getting that data, what was your experience on actually being able to communicate with some of those systems, right? And the reason I ask is because it felt very challenging on the technical side. A lot of those, I don't want to say proprietary, right? But they're
Mm-hmm.
basically third party vendors that create these like bins and hoppers and
Mm-hmm.
screw conveyors with those load cells. They're not, how would I say, very well documented, and they
Yep.
usually communicate over like some old protocols. I
Mm-hmm.
remember working on like RS 485 and just like
Oh
doing
yeah.
weird things over heart. Like, was it easy for you to get the information you needed, or was there a lot of like work on that side?
So generally speaking, it's never particularly easy to go get the information. Having said that, in a couple of the more recent experiences, when we've gone through and looked at it, there someone or someone's in the past have already gone and solved those problems, right? So there's already access to the weigh scales where we can go and collect that information. It's more so the,
Hmm.
how do I go and mirror that data stream without disrupting some of the older legacy systems. And so on the two instances that we've done something similar to this, we went and we looked at the legacy systems, and as we are going through the process of looking at the legacy systems, we basically know that we don't want anything to do with it. And we don't want to
Gotcha.
go in and attempt to do this within the legacy systems because of all of the issues it's going to have. And so, in the couple of times that we've done this, as this is kind of the first instance, it
Hmm.
was very much along the lines of yeah, it was very much along the lines of, can I get this information? How can I get this information as easily as possible just to go prove where we're at so that we can go and eliminate as much of the waste as needed. In future states for a lot of these, as we were to go through and replace control systems, which is a significantly longer process, right? But as you go through and replace control systems and redo entire facilities, that becomes the process of, hey, maybe we can go upgrade those scales. Maybe we can go upgrade some of these other things. And as we go through that, or I mean, I feel like everyone who's dealt with Mettler Toledo scales and tried to go pull data out of them has the same horrifying realization of, hey, this looks, within 5 or 10 years old, this should be super easy to have it. And then, like, I don't know,
So you
45
need an
minutes
Ethernet board. You need a
yeah,
board.
I was
Just
gonna
buy
say,
it.
2 hours and 45 minutes of phone call later, you realize that you
Yep.
need an Ethernet board that it definitely didn't come with, and then you have to
Yep.
go dig open the scale and see if you can go put the Ethernet board there. And I don't know, in about 60 to 80% of my experience, no, you cannot go upgrade those scales. It is time
Mm.
to go buy new scales. So we've also gone through, and I have looked at like specifically those old Mettler Toledo scale, and even not that old Mettler Toledo scale issues in the past, and it changes it
Yep.
from a low to medium dollar. Uh, yeah, it changes from a low to medium dollar project to a, this is going to be really expensive because we're updating dozens and dozens of scales. Having said that, I've done kind of entire retrofits and build outs, less of pet food. I did a couple of chocolate facilities. And as we went through that process, there was a lot of old technology that you just have to get through the process of, no, we cannot integrate with this. Do I put sensors on top of it? Do we go through the process of replacing it? Is the data not particularly that important is the data not particularly that important? Can we get by on a, call it a phase one, without having that data? So having gone through those experiences, I wanted to come up with a solution and kind of like an implementation that we've done a couple of times to go and kind of share. This is a very specific instance, and a lot of the work that we've been doing over the last couple of years on the Kaplan side has been, how can we be very specific and intentional about these solutions and allow them to go through the process of growing. I also find that it's a lot easier to show return on investment on a, I don't know, a couple $100,000 worth of project that you can go deliver over the course of a couple of months, or a month, as opposed to including, software and hardware and all that, as opposed to, hey, let's go retrofit your entire facility. It's going to cost you $3 million in today's hardware, and we're just going to go live here for the next 5 to 7 years of our life. And I'm not sure anyone wants to go live at these facilities for the next 5 to 7 years of their life anyway.
I mean, everything's got a price, but look, I think that this further maybe reinforces my opinion on the entire MCP or MTP movement, because I
Mhm,
think that there's still a lot of work that needs to be done at the architecture or infrastructure side
mhm,
before you can even get any amount of that data into something that can then leverage said data, right? And I think it's definitely an opportunity, but I think that when it comes to at least operations or plant floors, I think that the current state of most manufacturers, I don't, of course,
mhm.
we can argue about the percentage of those, even in larger companies, is still fairly behind to be able to just transfer out that information in a tangible form, right? And again, we can also argue that you can, in theory, use some weird converters, and I'm sure you
Hmm.
can plug in and tap into those even Mettler Toledo scales without the Ethernet board and
Yeah.
some kind of a strange way. But is it worth the effort? Is it worth the engineering time?
Hmm.
It becomes a very hard question to answer. Let me ask you a different question. On the organizational side. So, in my experience, it feels that depending on the group,
Hmm.
even once you've delivered the data and you've built out a platform that shows them to some extent explicitly, right, but provides
Hmm.
them the information they need to make a decision, it still feels as if they're so rooted in their past ways that they're just not using the platform to its fullest extent, right? So I guess I'm wondering,
Yeah.
what have you had to go through with those groups to say, hey, here's a batch that failed once again. You didn't look at the readout of the screw conveyor that indicated 15 pounds instead of 10. Like,
Hmm.
why, right? Like, what kind of maybe training or conversations do you go through to get them to utilize the data?
Yeah, so I think that it's a really good conversation, and I think at the end of the day, that is very much the crux of the issue that Vlad, you've certainly heard me talk about, of kind of historic systems integration work, right? Of we
Yep.
come and we provide the data, and then it's a good luck. There's very little training. There's very little enablement. There's hey, you guys wanted these five dashboards. We have gone through the process of delivering these five dashboards. I always like to joke the handover is like five engineering PowerPoint slides written by a hungover engineer on the drive to site the morning of the handover. Only written in a way that like an engineer may understand, and there's probably not an engineer on staff, right? And like they're delivering to operations folks. So
Yep.
I think what I find is that the data, like providing that data without actionable training, without actionable after work, is not going to set groups and organizations up for success. So particularly what I like to do is hopefully provide more than just the data, right? Like, so I don't want to say, hey, we're 50% over this particular ingredient. When I look at a project like this, it's the, hey, we've found this data. Let's go through the process of actually correcting the problem and doing it in a way that hopefully it corrects the problems long term. From that point, it's hopefully walking down the path of, hey, we've been able to do this. Can we continue upstream, or can we start on the backside of the line and continue to work other projects where we're showcasing what this information is? I would say, and I wish it wasn't true, is that sometimes going and showing and sharing data and going and solving problems of, hey, someone's full-time job doesn't have to be like erasing the whiteboard and updating the schedule, and then walking around 15 clipboards from group to group to group, so we all know what we're going to do over the course of the week. um, like I wish that lots of groups would be like, yes, let's go through the process. We find value in that. A lot of the times you're not going to go find decision makers who understand the problem when it comes to that. A lot of the times you'll find decision makers who will be like, hey, this is a $500,000 problem, or this is a $3 million problem. Let's have a serious conversation about how we can go solve this waste problem.
Hmm.
Or we just threw out, I don't know, 40,000 bags of dog food. We just threw it out because, we had, I don't know, five times the lethal dose of fish oil or krill or whatever this is in it. We shouldn't allow ourselves to do this again because it was a very expensive batch. And all of these raw material ingredients that we put in are very expensive. So this isn't the path that we want to go down. How can we provide safety rails and framework so that we can do it? And then in my experience, some of the most important parts are, while you want to go train the folks who are going to work on it, you want to go provide the data in a way that shows the decision makers that they're in the process of saving this money, right? And a lot of times that directly connects with dollars, right? So if a gallon of fish oil is $50 and we are measuring that you're putting in 1.5 times, and so we've just dumped, I don't know, 1,000 gallons of fish oil over the course of the last month into in excess. That's real money. So how can we
Hmm.
go through the process of identifying this is the waste, share them the waste, and then share with the decision makers the remediation strategy of that? I find that typically that is the path to success, of going and again kind of training and enabling down, but going and reporting up of, hey, we've got this waste, or hey, we've got this safety issue, or hey, we found these three problems quantify into, this dollar value, or this potential loss of life, or these OSHA violations, or any of these other items, and then going through the process of offering that remediation path and strategy.
Yeah, and look, I think that for better or arguably worse, a lot of those conversations are typically isolated from the engineering teams.
Mhm,
And so a lot of times, they're very concerned with technical problems of the system, but they don't have necessarily
mhm,
the visibility and the scope to understand. And, I was surprised by this until I was maybe 3, 5 years into my career and started
mhm,
talking to plant managers as to
mhm.
how little visibility because of lack of data they truly have into those issues, right? I'd ask
Oh,
questions like, hey, like,
absolutely.
well, yeah, like, hey, like we lost, obviously you look at some kind of a printout from their ERP, we lost 40,000 pounds of product last night. It was
Mhm.
discarded. And I would ask, well, like, why? Like, do we know why that happened? And I would just get a blank stare, right? They have
Yeah.
absolutely like no idea why it happened because they don't have the information, the data necessary to
Mhm,
explain that issue. And you would be surprised, right? Someone who is outside of our industry, you would think that there's traceability, that there's
mhm,
information being collected, but a lot of times, the issue, let's say you described in like that specific like scenario, quality will pull a small sample size, they
mhm.
will go into a lab, they will test, and they'll say like, hey, like this entire batch needs to be dumped, right? And that's the
Yep.
the end of it. They're
Mhm,
unable to go back and trace like the set point was wrong or the
mhm.
amount of ingredients was wrong. They just don't have that opportunity at all, so they cannot answer the question.
Oh, absolutely. Now, I think that the vast majority of groups, especially the small to medium groups, don't have the ability to tell you what a golden run or a golden series of set points look like, and as to if they actually go run those, and why there are changes of when they don't go run those. I've had, we'll just say, conversations with plant managers who didn't believe that they were down for 14 hours over the weekend for a specific result, and I had
Yep.
someone there for 14 hours and they did not run for those 14 hours, and they're like, we did not have these problems. And at some point they're just like, okay, we didn't have these problems, and I'm like, well, this is the issue. This is the issue. I'm talking about that, Vlad. You've
Mhm.
got one more story kind of going and continuing on the data collection side. Can we go through and share that, please?
Sure. So I guess similar to what you've described, but I would say more of a in a discrete type of an environment. At the end of the line, basically, this specific facility had whiteboards where they would collect, the number of cases that have been produced, and using that as a proxy to their OEE for the entire line, right? So again, in a packaging system, you have different product transformation, but you have your case packer, your labeler, your palletizer, your filler, capper, right? So just an array of different machines that lead to a, I guess, package being completed and then palletized for the warehouse. And so the issue here was that it was very hard to figure out, number one, which machines or which machine was the bottleneck, what kind of issues did every machine have, and ultimately, are we on track to complete the order? Obviously, you have, like I said, a proxy on each line where you could see how many boxes we've produced. Let's say over like every hour, they basically would dot and then like trace the lines on the whiteboard. But it was very loose, right? So the operator had like plus or minus 5-10 minutes to get that number off like a digital type of a display. And so, of course, the data was not accurate most of the time because the operator would either be pulled off the line or doing something else, or feeding raw ingredients. And so, long story short, the facility was looking at ways to be more digital, but ultimately to drive what's called CI initiatives, right, or kaizens if you come from a Lean Six Sigma type of an environment. And so, the idea was to figure out how do we allocate capital for best use on our lines, right? And so for me, and I'm a huge believer, because I've seen the system work at P&G quite extensively, into what's called DDS, or daily direction setting. In a nutshell, it could be set to be a pass down meeting, right? So if you're running 2 shifts or if you're running 3 shifts, you always have a meeting to understand what are our top priorities. It could be three, it could be five, but long story short, this facility had a very loose way of conveying that information. They didn't have any, I guess, issue tracking or productivity tracking like I've described for any assets. So they would just come in, work on the line, and then based on, experience, and of course that also comes with its own challenges. If you have someone who's been there 10 years, they can explain and articulate it a lot better. If it's someone new, it's very hard for them to get up to speed. But they would basically say, well, like these are the three issues with the line. The team that's coming in next should be working on those issues. Well, good luck, right? And of course, as the operator leaves, they basically have no more responsibility or ownership of those assets. So the idea was, how can we collect just a starting point of data on each one of those assets to be able to say how well each asset is performing, what can we improve, where are the issues, where can maintenance focus on, but also, if we're having those meetings, we're not just guessing. We can reliably say, hey, the filler was down, which led to your capper. Well, obviously, like everything downstream is down versus, the capper is down, then the filler is backed up, and other assets, have a lack of product. So basically, getting just base OEE metrics on the line, but also on every asset. And so, of course, I don't want to go too deep into this because we're obviously running over time. This prompted the conversation of how do we collect this data? How do we present that data? Questions around, do we show that to the operators and plant floor? Do we show that to management? Do we show that again to the executives across like different facilities, or just keep it to, let's say, supervisor and ops manager type of an environment? So a lot of different considerations. You start collecting at the site. You start getting operators to input some additional information on the HMIs, which, again, there's a lot of, I want to say, like depth to this project, but basically collecting the information from PLCs, storing that on a server, historizing all of that information, feeding it back in a more synthesized way into reports, feeding it back onto the production line so that you can make better decision to invest your capital on some of those assets.
Absolutely. No, I think that is good. When you were talking about the DDS, or the handover meetings, I was thinking to
Yep.
myself how it's interesting because I have now reached the point in which I've worked with groups long enough to go watch them start the handover meetings, watch how significantly better it runs after those 15 minutes of handover meetings, and then watch them decide they're spending too much in labor and start cutting those handover meetings and watching the production go the other way because
Yep.
we are no longer
Yep.
doing those handover meetings. And so I think
100%.
I think that is interesting. Let me ask you a question. You brought up a bunch of very good topics and commitment or topics there, Vlad.
Hmm.
I think most of us can agree that some sort of digital OEE solution is the correct way to go. Do you think that we're going to go find a relatively easy, relatively straightforward offering that we're going to see lots of groups go and implement as a phase one before they go try to get in and go do work, at the PLC level, so we can go get those, 5 milliseconds. So we can go have the data at 5 milliseconds. Or do you think that the groups who are going to do it are going to go through this long process before they have that information? And we're just going to see a lot of groups continue to run without good, believable OEE data.
I want to say like most greenfield facilities, over the
Mhm.
last like 5 years or so, have some kind of a way to monitor OE.
Oh,
To my
absolutely.
yeah, I think like to my earlier point, again, it depends on the teams, it depends on their appetite, but ultimately, I just, how would I say it? I would struggle to cut a corner at this stage because I think how would I say it? Any issues that arise in 1 to 3 years are going to be as a result of which route you have picked for collecting your data. So I would be very careful in these early selection processes before committing to one solution or another. I think there's a lot to be said on more process oriented industries versus more discrete oriented industries, or mixed industries, and the types of solutions that work, I want to say, across both of them. But long story short, I think yes, you can spend a little bit less money and put in an extra set of sensors to, collect, let's say, the number of cases passing by into a single type of an isolated environment. I guess that's not how I would do things, but I
Mhm.
could see why certain groups that maybe have less engineering staff and less CI type of initiatives would do it that way. So I guess I don't have a solid answer, but I don't think it's going to converge to sort of like one player in the space. I think there's always going to be room for, depending on the size, depending on the industry, and depending on, the team left with that solution.
Mhm.
I guess it's going to be different.
I agree. The more and more I look, especially into the OEE space, the broader and broader the competition is. Everything from the ERP to your process historian to standalone solutions to every major player having multiple iterations of that.
Yeah.
Vlad, this has been fun. Are we answering the final questions for ourselves today? Or are we
Let's do it.
wishing everyone? Okay.
Yeah, let's do it.
Uh, Perfect. Vlad, I guess I'm going to go ask you that for longtime listeners, you guys know that this is my most fun question. It is predict the future. Vlad, where do you think that the future of manufacturing or the future of manufacturing intelligence implementations is going to go in the next 2 to 3 years?
Yeah. So look, I guess I think it's important to bring in AI into this whole conversation when it comes
Mhm.
to the future. As I've mentioned in one of my, I guess, recent LinkedIn posts, I believe that there is a huge opportunity in everything that is outside of operations for AI. I still believe that a lot of work remains to be done when it comes to control systems and operations and networks and data when it comes to actual manufacturing. And I think, the best analogy that I can come up with in a couple of seconds is, if you're looking to improve your health and you're going to, for whatever reason, decide to start taking steroids tomorrow, thinking that it's going to solve all your problems, it's just simply not going to work, right? Until you have a clean diet, until you actually show up to the gym, like you need to put in the work before you get more gains from those types of compounds, right? And so
Mhm.
the idea here, or the parallel here, is I think if you think that AI is going to come in and solve all your problems while you have networks that keep going down, while you have a lack of modern infrastructure when it comes to software or hardware, I think that a lot of manufacturers are going to lose a lot of capital as a result of trying to go too fast where they should have focused on fundamentals.
Absolutely. I agree. I'll go ahead and give my future predictions.
Hmm.
I believe that in the next 2 to 3 years, we're going to continue to see the rise of AI. And I think that is going to be the gold rush of the manufacturing data. I think at that point, we'll see how bad all of our historic data collection has been and go through significant steps to remedy said data collection and said data analytics
Mhm.
so we can go leverage these tools. I'll
Yep.
also mirror similar comments that Caleb had last week of and things that I feel like I've been saying for several years is that we're going to see groups who are on the bandwagon of the data collection, of the data analysis, and they're able to get better and they're able to not just survive but thrive. Whereas I think we're going to see groups who are kind of in this middle ground of they're not 100-year-old company that has only made cardboard boxes on the same pieces of equipment for 100 years. And they're not going to go embrace the need for data and they're going to go try to do it with just more and more labor hours. And I think we're going to go see them fail and get bought up or become smaller and smaller versions and iterations of themselves.
Yeah, absolutely. What I guess what have you got career advice wise for us, Dave?
Absolutely. So I think my best career advice I have, especially for kind of early to mid-career people, or perhaps people who are wanting to make a change or learn something new, is to not limit yourselves to just the knowledge and resources that exist at work. Nowadays, it's super typical to have 40 or 50 hours of work that you have to go do and complete every week, if not more, that doesn't get done. But a lot of that learning and a lot of those other opportunities that you're seeing people succeed in their career are done beyond those normal 8 to 5 timeframes. You'll go see people who are successful in going to conferences and other things, but the majority of kind of early and mid career folks aren't necessarily able to go there or don't have great companies and organizations who are going to allow them to do that. So if you're interested in going to figure out how to do something, by all means, attempt to do it within the confines of work and employment, but don't let that limit yourself to the knowledge and things that you're interested in looking at.
I like that. I like that. I will dare throw in an invite to tech Twitter. There's a lot of AI building going on, and people are building interesting things, using AI or otherwise. Usually not for the industrial space, but
Mhm.
I also believe that you should be like trying and building things and learning things. Like there's a lot to be said on that side for sure. Um, for me, as a result, I guess, of certain recent engagements, I think I've realized that a lot of people in our space, and not just, I would say, like not just in our space, right, and not just on the engineering side, seem to be afraid of asking questions, right? And I think there's always a general stigma of asking a quote unquote dumb question, but the reality is that's the only way to learn. So I always encourage engineers, and I almost, I keep asking people when I'm explaining a certain topic, like, hey, do you have any questions? Do you understand this? But the advice is don't be shy to ask questions. I think it's much better to understand the topic, right? And if it takes someone repeating it a couple of times, um, it is what it is, then to leave and not be on the same page, or keep thinking about like what if I would have asked, right? So I think like ask the questions. If you're unclear on something, people are usually more than happy to re-explain or explain a little bit deeper on all fronts when it comes to tech or business.
Absolutely. I would agree with that. Vlad, I know that you've got a
Yeah.
book recommendation here, so I'm going to let you go ahead and give the book recommendation for today.
Yeah, so as you know, I guess for a variety of reasons, or I guess for some reasons, I am drawn to the culture of Navy SEALs, right, which includes Jocko Willing. And so the book that I've been listening to, actually, I'm on my second listen, is Can't Hurt Me from David Goggins. And so he's also, you've probably seen some of his content, maybe on YouTube, maybe on LinkedIn. is an ex-Navy SEAL that did incredible things in his life, including some ultra marathons that I would not have even thought humanly possible. It's the number is, I think it's Badwater ultra marathon, and it
Hmm.
is 135 miles long through the Death Valley, on the hottest months of that location, and you're explicitly asked to sign waivers, because people actually die in running the ultra marathon, and he has run it multiple times. But long story short, I think it's interesting to listen to achievements of people who have overcome things, whether that's physically or work wise, that I at least think are absolutely out of reach. And then you, I guess, to some extent, or better or worse, to compare yourself to them and like, hey, like, I can do more. I guess that's the conclusion that I would get. But yeah, super interesting book. It says like life story, but also a lot of takeaways and systems and processes that he used to, I guess, launch his Navy SEAL career and then beyond that as well.
Absolutely. So I don't have a particular new book
Mhm.
update to share. So especially any work information. I will say, I guess I'll go make the mention. Ignition 8.3 beta docs have dropped. So that's what I was spending some time earlier this week looking at on the technical side. Beyond that, I think we're 6 or 7 weeks out from ICC. So I would definitely go and pay attention to all the fun, interesting content that's coming out with that. There is a Prove It series of Prove It sessions that are going to go happen at the conference, which I think are going to be super interesting.
Mhm.
I mean, I probably will have less time at ICC to go watch the Prove It sessions than I did at Prove It, in which I had very little time to go watch the Prove It sessions. But I'm super excited to see who's going to be there and what's coming out. The conversations I've had about that all point to them being very exciting. So you guys go stick around, watch for what's going out with that. On my side of who should reach out and who wants to help, I mean, if you guys are enjoying the conversations, if you guys are enjoying Manufacturing Hub, please go connect with me, follow along, follow Manufacturing Hub and Vlad on LinkedIn, on all of those other fun places that you're doing. If you've made it this far and are interested to go have a conversation about unlocking data or solving raw material waste or doing something along those lines, or you guys have Ignition that you're using as a platform and you're looking for some expert help when it comes to that, please go and feel free to drop me a message. Would love to have a conversation, if only to discuss what you're doing. How about you, Vlad? How can the listeners reach out and help you?
Yeah, I would say, look, I'm always happy to have a broad set of conversations as long as they're related to manufacturing and industrial automation. I've had conversations with, partners of private equity to engineer or operator even of a specific line. So if you have interesting topics, if you have thoughts on how things could be better or should be better, how AI is utilized in a general sense, how certain software and hardware landscapes look like, more than happy to discuss any and all of it. So send me a message on LinkedIn, and we can either continue the conversation there or get on the call, if that's where we want to take it.
Awesome. Vlad, thanks so much for joining me, Dave. I don't
Mm.
know why I said that. It's because we normally have a guest and it's just muscle memory at this point. But everyone, thank you so much for hanging out with us this Wednesday. We'll be back next Wednesday at a slightly earlier time when we've got Kevin McCluskey on from Inductive Automation as we go continue our coverage of Ignition 8.3 beta and the run up to ICC. If you guys can remember to do the like, share, subscribe, follow us, all of those fun things. Thank you guys so much. And again, shout out to our podcast listeners. You guys are amazing. Thank you for making it